Welcome to Study Loop.
So in this question, we have 4 polarizers and we have them placed in succession. And they have different orientations. The first one has a vertical axis. Second one has one that is 30 degree to vertical. Third one is 60 degree to vertical. So 60 degree can be more like this. And the last one is completely horizontal. So they rotate in a clockwise direction. Or it could be counterclockwise, but the one I'm drawing is clockwise. So eventually rotate from vertical to horizontal. So first question, ask us to calculate what fraction of the instant on polarized light is transmitted by the 4 polarizers. Again, I'm calling this I naught. After it passes through the first one, only half of it is left. After it passes through the second one, third one, and the fourth one, every time we multiply by cosine squared theta, where theta is the difference, is an angle made between the axes of 2 successive polarizers. But if we look at this, if we look at the angle with respect to vertical, we have 0 degree to vertical here, 30 degree to vertical, 60 degree to vertical, and 90 degree to vertical. So the angle difference between each of them is 30 degree. So what happened will be I2 will be equal to I1 times cosine squared 30 degree. I3 is equal to I2 times cosine squared 30 degree. I4 equals I3 times cosine squared 30 degree, etc. And so what is I4 in terms of I1? I4 equals I1 times cosine squared 30 degree to the third, because we apply it 1 time, 2 times, 3 times. But I1 is half of I naught. So it's half of cosine squared theta to the third times I naught. And we plug in the numbers. It's cosine squared 30 degree to the third over 2 times I naught. Okay, and now we plug in all the numbers, and this gives us 0.211 I naught. So 21% of the light will survive in this case. But now we're asked, can this light be decreased by removing one of the polarizers? And the answer is yes, of course. And why do we say that? Because, let's consider this group from the first polarizer to the third polarizer. And we can consider removing this middle polarizer. When the middle polarizer is over here, we have the intensity of light is decreased twice, each time by cosine squared 30 degree. So when I1 to I3, I3 equals I1 times cosine squared 30 degree, and it's applied twice. So cosine of 30 degree is square root 3 over 2. So its cosine is 3 over 4, and square, that's 60 over 9, I1. So this is what we originally had. But if we remove this polarizer, then the intensity will only be decreased once by an angle of 60 degree. Then what we will have instead is we will have times cosine 60 degree square. And what is cosine 60 degree? Cosine 60 degree is 1/2. So when we have cosine 60 degree squared, that is 1/4. I1. What is 1/4? Is 4 over 16 I1. So compared to the previous case, we can see it decreases from 9 over 16 to 4 over 16. So by removing the second Polaroid, we can decrease the intensity of the light. And if so, the question asks if so, which one, but it can be the second. Actually, it can be the third as well, because we can see that, oh, by removing the third one, it's symmetric because the third one also makes a 30-degree angle with the one previous to it and with the one after it. So by removing the third polarizer, we can also reduce the amount of light that passes. We can also, remove the amount of light that passes through. What about the first one and the last one? No, not these two, because both the first one and the last one do filter out some light. And by removing the first one and the last one, we will actually increase the amount of light transferred. So for B doesn't really ask us to calculate anything. It's a yes or no question. So the answer is yes, we can decrease the transmitted light by removing one of the polarizers. And I can remove the second or third. So that is the answer. And if you really like calculating it, you can do the same calculation. You can do I4 equals I1 times cosine 60 degrees squared times cosine 30 degrees squared. So that I1 equals I0 over 2. And then if you plug everything inside, what you'll get is you'll get a percentage of 0.0938 I0. So it goes from 21% all the way down to 9%. So it's a little bit over the half, just like we can see here. It goes from 9/16 to 4/16, over half. It's reduced to remove one polarizer. And yeah, so that is for part B. What about part C? Can the transmitted light be extinguished by removing polarizers? Yes, of course, because by observing, we see that, hey, this polarizer is completely vertical, and this polarizer is completely horizontal. If we ignore all these two in the middle, what will happen is you have unpolarized light first passing through a vertical one and then passing through a horizontal one. And we know in this case, all light will be filtered because you have I4 equals I1 times cosine squared 90 degree, and cosine 90 degree is 0. So you will have I4 equals 0. So for the middle two polarizers, if you remove one of them, the intensity will decrease by over half. But if you remove both of them, no light will be able to pass through. And the reason is because you have the first polarizers completely vertical and you have the last polarizer completely horizontal. So they are in perpendicular directions. So you really would expect that no light will be able to pass through this combination. But when you add these middle polarizers that eventually rotates from vertical to horizontal, what happens is you are guiding the wave. So the wave was vertical. It was initially vertical, but after it goes through the first polarizer, only the first polarizer, because it's 30 degree to the vertical, it actually gives the wave a little bit horizontal component by casting the wave onto this other direction. And then you rotate a little bit more. In this case, again, you reoriented the wave, so you give it a little bit vertical, you give it a little bit horizontal component by mapping the wave into a 60-degree direction. And finally, you have this vertical one. So by guiding the wave into a different direction after each polarizer, you are slowly rotating the wave from a vertical wave to a horizontal wave. And that is what these middle two polarizers are doing, and that's what allows the wave to pass through the final polarizer, even though it is completely perpendicular to the first polarizer. So this is a technique that is also applied widely in industry, and it has a lot of applications. But it's also interesting to know that sometimes by adding polarizers, you can actually increase the amount of light transmitted